maybe I'll give it another minute and then we'll get started with container types. So for anybody who's here at the moment, container types are the things that contain the data types that we just mentioned. So things like Booleans, things like strings, integers, and floats. So these all go into container types. We're going to talk about lists. We're also going to talk about tuples, sets, and also dictionaries. I'll go over some of the methods. And then at the end, again, we're going to have a couple of true or false statements, and then hopefully get into slicing before the next break. Okay, cool. So I'm going to go ahead and get started. So a list is a collection of ordered and changeable items that allow for duplicates, and they're denoted, and I should mention this as well, to create a comment in the notebook, you use asterisks. No, sorry, asterisks. I think it's actually a pound sign. A pound sign to create a comment in your code. So I believe the same goes for R if you've worked in R. But yes, so you use a pound sign to, again, create a comment in your block of code. So a list, again, is a collection of ordered and changeable items, and I'll explain that in a little bit more detail. It allows for duplicates, and to create a list, it's typically denoted, it's actually only denoted with square brackets, and the items are separated by commas. So we can actually create our own list. So if we create a list of fruits, we create some variable name called fruits, and we assign it with the equal sign, one equal sign. And to create the list, we use square brackets. So we can list a couple fruits. It's similar to like a grocery list. I think that's the best analogy to recognize what a list is. So again, as you can see, a list is denoted with square brackets and then separated with commas. And this is a list of a bunch of fruits that are strings. Again, we know that they're strings because we've used double quotes. You can also use single quotes, whatever's faster for you or easier for you. And there are a total of 6 items in our list. So to run, we press Command Enter as a shortcut or Control Enter, depending on your machine. And now we can print the list of fruits. And we can see that the list is actually in the same order that we've created the list in. So apple, banana, cherry, orange, mango is identical to the way we've structured it previously. Now that we have this whole list, we can also see some of the characteristics of lists. So we can start by maybe looking at adding to a list. And you can imagine with a grocery list, you might add things, you might remove items that you might not buy. And the way we do that is we use this append method. And I won't be talking about methods in too much detail and what they are exactly, but for the time being, just have faith in me and trust me that this is what we'll use and this is how you add things to a list. And let's say to our list of fruits, we want to actually add another item of apple, say maybe gala apple or whatever the case may be. And when we press Command Enter to run that, we can see now that our fruits list has 2 items called apple. And this is one of the characteristics of lists. They allow for duplicate items. Another method related to lists are popping. So we can pop the last item of the list using the pop method. So when we call this, what it pops out of the list is the last item. So the apple that we've actually just added. And if we pop it out, we see that it tells us exactly what gets removed. And then when we call fruits again to see the list, we see that it's identical to the first list we made and has removed the apple item that we just added. And now I also mentioned that lists are ordered. So we can actually index into them, and we'll talk about indexing shortly. But for the time being, indexing is done with square brackets, and then we indicate the index that we want to look into. So Python actually starts from the 0th index. So the way it works is apple would be at the 0th index, banana would be 1, cherry would be 2, orange would be 3, and so on and so forth. So if we look on our list at the 0th item, we should get apple, and we get apple. And the thing with lists is we can actually change the item at that index. So let's maybe change this to another fruit. I don't know if everyone's familiar with pomelos, but those are good fruits. And we've now changed the 0th index of the fruit list to pomelo. So when we call fruits again, we can see that the list has changed, where previously it was apple, has now been updated to be pomelo. And you might be asking, what are lists useful for? Well, lists are, again, useful for keeping attendance, maybe even grocery lists. In the case of data analysis, you might use a list to store data columns. And you'd want to use a list over the other container types that I'll mention later, because they are able to be updated and you can change items in the list. So hopefully that was clear. And you guys understand what lists are for and how they can be used and the best case when to use them. The next thing I'll be jumping into are tuples. So tuples, similar to lists, are a collection of ordered, but they're unchangeable items. So once we create a tuple, you can no longer index and then change that item into something else. Tuples also allow for duplicates, and they're denoted with round brackets. And they're separated by commas. So we can create a tuple here. So we'll create a sport variable, and we'll assign it with the equal sign, just one equal sign. And then we'll start off by denoting round brackets. And then within the round brackets, or yes, within the round brackets, we can start to specify a couple strings. So we can specify hockey, basketball, baseball, and tennis. And now with our tuple, we can see that we have all the values that we've just listed, and they're in the same order that we've created the tuple in, similar to that of lists. Now we can also create another tuple. So I'm just going to copy this and paste it here and add a duplicate value, and to showcase that we can have duplicates in a tuple. So when we call this again, when we call sport, we can see that tuples do allow for duplicate values. Now I did mention that tuples do not allow for changeable items. So we can actually try this. So we can try indexing into a tuple, similar to what we did with a list. So we can try to index into the 0th index. And we can see that we can index into it. But if we attempt to change it, let's say we change this to another sport, say cricket, we get an error. So tuple is very similar to strings, where once it's created, you can't change anything about it. Now with tuples, and I should have also mentioned this with lists, but they can also contain all the main data types that we've mentioned previously. So if we create a random tuple, we can have it include the string that we learned about earlier, have it contain the Boolean value that we learned earlier, as well as the integer value and the float value. So this random tuple can store different types of data types. And when it comes to tuples, you might be asking, when might you use a tuple over a list? Well, if you think about it, the tuple is used when you don't want to change anything anymore after it's created. So a great example of this would be, say, the days of the week. Days of the week. Again, the days of the week are pretty straightforward. So you have Monday, Tuesday, Wednesday, so on and so forth. And I don't think they're going to be adding any other new days anytime soon. So if you're creating a tuple for the days of the week, or if you're creating a container type for the days of the week, it makes sense to use a tuple because we won't be updating or changing the days of the week anytime soon. And another case where this might be useful is in data structures and algorithms, where you want to keep an unchanged list of things. And you can also use tuples, say in web design, where you might have options for, say, sizes of t-shirts, or options for different types of clothing. Maybe your store only offers t-shirts or pants. You'll want to make sure that the option types are restricted to those things only, if you don't have inventory for those other things. So that's kind of the use case for tuples and how they differ from lists. The next thing we'll be talking about are dictionaries. And you can imagine them to be very similar to the actual dictionaries that you use in real life. So what a dictionary is it's a collection of key value pairs that don't allow for duplicates. And they're denoted with curly brackets, denoted by curly brackets. If you don't know where the curly brackets are, shift and then the square brackets, denoted with curly brackets, and key value pairs, separated by semicolons. And we can create our own dictionary. And I'll explain the analogy in a little bit more detail, but let's assign some variable user1 and then assign it with a single equal sign, and then denote that we're creating a dictionary with the curly brackets, and we'll state the keys. So the keys are going to be name, and then we're going to separate the name from the value itself. So the name might be Dennis. You might want to enter your name here. Then you can enter another value, age. Then a couple more details that we want to add. Maybe in school is equal to true, and distance from some school or from some location is some float value. And as you can see, we've actually stored all 4 of the data types that we've learned about previously. So we have a string, we have an integer, we have the Boolean value, and we also have a float value. And I should put a period there. So we've created a dictionary of name, age, school, and distance. And you can think about an actual dictionary where, say, you look up a word and you're looking for the definition. The key is similar to the word, and then the definition is similar to the value that you assign to that word. So that's one way to consider dictionaries. And we can create another user. I'll just do this quickly. You don't have to do this. So we've created 2 users. We've created 2 variables, actually. So user1 and user2. And you can see that the dictionaries are different and contain different values. And one thing we can do is we can index into these dictionaries to see exactly what the value is. So similar to that of a dictionary, you look up the word and then you find out what the definition is. If we call the variable user1 and we want to see the value of the name key, we would index into the variable user1. And then to index, we denote that with square brackets, and then we'd call the name key. So this is the key called name, and maybe I'll do a little formatting thing here. So it'd be dictionary. So it looks something like this, my dictionary, square brackets, and then you'd enter the key here. So what we've done is we've entered the dictionary, square brackets, and then the key name. So when we call this, and you want to denote the key and the value with semicolons. So let's run this again. And we'll see that when we index into the user1 dictionary and look into the index or the key name, we actually get the value Dennis. And we can do this for user2 as well. And we'll see we'll get each dictionary's unique value. And when I started my explanation of dictionaries, I mentioned that dictionaries don't allow for duplicates. So let's take user2, we'll copy and paste that. And then let's create another instance or another key value pair of name. But now we've created a second variable called user2, and we have 2 key value. We have 2 key value pairs. That's better. We have 2 key value pairs that are both or 2 keys that are the name. So what ends up happening when we call this, or if we run this block of code and we call user2, we'll see that the name actually updates to just be John. So what happens here is the dictionary recognizes that there's 2 similar keys and takes the last one that we have written in our block of code. And that kind of showcases how blocks of code run. They run from the top down. So the last thing that they see will be the last thing that they store. So in terms of name, it stores the last name that appears. And if we want to try this again, and we want to create another name, we can see that it takes the last name in the key value pair that we've created. So there's Jane, there's also John, and then glass. And you can see that in this case, the dictionary only takes the last one and doesn't allow for duplicate key value pair. Similar to lists, where we can change parts of the dictionary, we can also do the same with, we can do the same thing with lists where we could change with dictionaries. So let's say we took user1. So the original user, it has my name, my age, my fact that I'm in school, and some distance. And we can change, let's change the name. And let's change the name to something more substantial. And now what happens when we call the dictionary again is we can see that the name has actually changed. So the value of the key value pair has been updated. So that's one useful trick with dictionaries, is that you can actually update the key value pair. Another thing you can do is actually add another key value pair. So let's say we add location, and we want to set our location to Toronto. When we call user1 again, we'll see that we've added this key value pair called location. So with dictionaries, what you can do is not only can you that you can avoid duplicates, but you can also add and change key value pairs. So maybe one comparison that might be useful is comparing dictionaries to lists. But in this case, you have key value pairs that are associated with some storage key, and then the values indicated after the semicolon. Whereas lists, you can also do the same thing with adding and removing parts of the list. With dictionaries, you can kind of see where they connect. And you might be wondering, why might you use dictionaries over a tuple or a list? Well, dictionaries are useful when you want to store unique information. So you can imagine user profiles. We've kind of created a user profile here. There's a name, there's an age, there's a distance and a location. So it's useful in that sense. And you can also use dictionaries for databases for analysis. So say you have a whole bunch of data with reaction time. You want to check every index that has the reaction time and store all those reaction time values associated with the reaction time key. So that's where you might use dictionaries. The next and the final container type we'll talk about are sets. But what sets are unordered collections of unchangeable items. So now that they're unordered, this doesn't allow for duplicates, and I'll explain that in a little bit more detail. And the way we denote sets is with curly brackets, and again, separated by commas. So we can create, my set. And now we've created a set, but when we call the set, we'll see that things are a little different. So in sets, the order, when we call the set, is no longer the same as the order that we've actually inputted the set. So as you can see, the first value is no longer Young, it's now Avenue. Bathurst is the same, but Don Mills has changed, and Steele has changed, and Young has changed. And what that leads to is that you can no longer index, because the order of the set will always be different depending. The order of the set will always be different. So if we try to print this again, it changes once again. So the trouble with that is we can no longer index into the set. Same way we did with lists, tuples, and with dictionaries. So if we want to access the 0th index, we can't do that with sets anymore. And because we can't access, we also can't change anything anymore. So that's what I mean when I say that sets are unordered collections of unchangeable items. And they're also useful in the fact that they don't allow for duplicate values. So we've already created a set of streets. If we create another set of, say, animals, maybe let's say pets, the type of pet you have, if you have a bunch of pets, fish, maybe you have a dog, a cat, and maybe you have a set of dogs. When we call this set and when we run it, we'll see that, oops, this is not, there we go. But we see that the unique values are the only ones that are outputted when we call the set again. So this is what I mean when sets do not allow for duplicates. As you see, we inputted 2 dogs that we have as pets. But when we call the set pets, we are left with the output of just the unique values of the set. And this is helpful because you might have duplicate entries in a sequence and you want to only output the unique values. And sets are also useful when you consider probability applications. So things like unions, intersections, and differences. If you plan to look into probability, sets are something you'll tend to use when working with that. And another advantage of sets are for searching. Sets are actually one of the fastest container types for searching, as opposed to lists and tuples, because they cut down on duplicate values and leave you with just the unique values to check if something is in a set. And I'll explain that in a little bit more detail when we get into logic statements and working with sets and for loops and whatnot. But those are the 4 container types that I plan to talk about today. And now to check if you were listening again, we have a couple true or false questions. So again, true or false, you can update a key value pair in a dictionary. And maybe I can explain this again. So let's create a dictionary here, my dictionary. And let's say it has some key and some value 5. So we've created a dictionary, and let's try to change this key to another value. Let's change it to 10. And when we call my dictionary, we can see that we've updated the key value pair in the dictionary. So this one will be true. The next one, so true or false in this poll, and then we'll open up another one. So true or false, sets allow for duplicates. Okay, and maybe just to showcase this, so we'll create a set and we'll create some animals again, so dog. And when we run this, and then when we call set again, we'll see that we're only left with the unique variables. So sets don't allow for duplicates. When we call the set, we see that we're only receiving the output of just the unique values. Okay, and then the last true or false for this section. So true or false, tuples only allow for one data type. And you can try this out yourself. You can create a tuple, and recall that a tuple is denoted with curly brackets. And we can try to put maybe some string, then some Boolean value, and maybe some integer, and maybe a float. And we'll see if this runs. And it runs, and it looks like the tuple can store for multiple types of data. So true or false, tuples only allow for one data type. This is false. Okay, looks like everybody's getting a lot of the material that I'm putting out, so that's good.